These are Calc 3 Exam 5 solutions for the 11 a.m. class. Number 1, f of x, y, z is negative k. You just need a bunch of arrows pointing down. And that's about it. Number 2, ds is given. It's a square root of dx dt squared plus dy dt squared plus dz dt squared dt. So the derivative of x, 2 sine t, is 2 cosine t squared. Derivative of the y is negative 2 sine t squared plus 5 squared dt. That comes out to be 4 cosine squared t plus 4 sine squared t. This is 4 plus 25, so radical 29 dt. So I'm integrating from 0 to pi over 2, radical 29. And then we're integrating x, y squared. So x is 2 sine t, y is 4 cosine squared t dt. Take out the 8, radical 29. Integrating cosine squared t sine t. If I do a u substitution, it's basically cosine cubed divided by 3 times negative 1. Okay, if we do a u substitution or double check the derivative of this is negative cosine squared t times negative sine t, and so you'll be left with sine t. So negative 8/3 radical 29, plug in pi over 2, you get 0, plug in 0, you get 1. So 8 radical 29 over 3. Number 3, f is x squared y cubed. So t squared squared t cubed cubed, negative y radical x, negative t cubed times t. That comes out to be t to the 4 plus 9t to the 13th and negative t to the 4th. dr is 2t 3t squared. F dot dr is 2t to the 14th minus 3t to the 6th. So the integral of f dot dr is the integral from 0 to 1 of 2t to the 14th minus 3t to the 6th dt. That's 2t to the 15th over 15 minus 3t to the 7th over 7. Plug in 0, you get 0. Plug in 1, you have 2/15 minus 3/7, which is 14 over 105 minus 45 over 105, so negative 31 over 105. Number 4, partial of q with respect to x is the same as a partial of p with respect to y, which is 5. Therefore, f is conservative. So fx is 6x plus 5y. Therefore, f of xy, integrate with respect to x, 3x squared plus 5xy plus a function of y, g of y. Fy is 5x plus g prime of y, and that's equal to 5x plus 3y. That makes g prime of y equal to 3y. So g of y is 3 halves y squared plus k. So f of xy is 3x squared plus 5xy plus 3 halves y squared plus a constant. Number 5, fx is x cubed y to the 4th. That means f of xy is 1/4 x to the 4th y to the 4th plus g of y. Differentiate. Fy is x to the 4th y cubed plus g prime of y. That's equal to x4 x to the 4th y cubed. That means g prime of y is 0, or g of y is a constant. So f of xy is 1/4 x to the 4th y to the 4th plus k. The easiest k to pick is 0. Plug in t equals 0, you're at the point 0, 1. Plug in t equals 2, you're at the point radical 2, comma 9. So f of radical 2, 9 minus f of 0, 1. F of 0, 1 is 0. F of radical 2, 9 is 1/4. Radical 2 to the 4th power is 4. 9 to the 4th, that's just 1. So the answer is 9 to the 4th, or 65/61. Number 6, we're going like so and like so and like so. So the integral along C is integral along C1 plus integral along C2 plus integral along C3. Along C1, y is 0, which means dy is 0. So when I plug into the original, there's a 0 somewhere, everywhere. So that's going to be 0, that's going to be 0. So I'm integrating, and I have 0, so the answer is 0. C2, x is 1. X is 1, that means dx is 0. And y is between 0 and 1. So if I'm integrating along the curve, dx is 0, that's gone. That's 1. So I'm integrating y squared dy, which is y cubed over 3 from 0 to 1, 1/3. C3, y equals x. That means dy is dx. And we're going in this direction since it's a closed path. X is going from 1 to 0. Right? So the integral becomes x, y, which is also x dx plus x squared dx, since dy is also dx. So I'm integrating x squared plus x to the 4th dx. So it's x cubed over 3 plus x to the 5th over 5 from 1 to 0. Plug in 0, you get 0. Plug in 1, you have 1/3 plus 1/5, so negative 8/15. So the grand total is the integral of C1, which was 0, plus the integral of C2, which is 1/3. The integral of C3 was negative 8/15. That's negative 3/15 or negative 1/5. Number 7, curl of f is ijk, partial with respect to x, y, and z, e to the x sine y, e to the x cosine y, and 6z. So the I component is nothing minus nothing. The j component is the opposite of nothing minus nothing. The k component is e to the x cosine y minus e to the x cosine y. So we have the zero vector. Div f, del dot f, so the partial of p with respect to x is e to the x sine y. Derivative of this with respect to y is negative e to the x sine y, and derivative with respect to z is 6. So the answer is just 6. Number 8, r of u is 1, 10u 1. R sub v is 1, 0, negative 1. I'm at the point 250. That means u plus v is 2, u minus v is 0. Add them up, 2u is 2, u is 1, v is 1. So u and v are both 1. Ru cross rv, ijk, 1, 10u 1, 1, 0, negative 1. I component is negative 10u minus nothing. J component is the opposite of negative 1 minus 1, which is a positive 2. The k component is nothing minus 10u. So negative 10u minus a minus 2 or 2, negative 10u. And I plug in u equals 1, v equals 1. So a normal vector is negative 10 to negative 10, or I can use any scalar multiple of that. So I decided to pick negative 1/2 times that vector, which is 5, negative 1, 5. So the tangent plane is 5x minus y plus 5z equals to some k. To find k, I plug in the point 250. So 5 times 2 minus 5 plus nothing is k, and that tells me k is 5. So 5x minus y plus 5z equals 5. Number 9, it does say orient it clockwise, which is opposite of positive, so I have to take a negative somewhere. Okay, so this 1, 0, 0, 0, 1, 0, 0, 0, 1. Quick word, we have an equilateral triangle with each side length of radical 2. Formula for the area of an equilateral triangle is s squared radical 3 over 4. So ds is radical 2 squared 2, radical 3 over 4, or radical 3 over 2. And the unit normal vector is 1, 1, 1 divided by radical 3. So curl f dot ds, or curl f dot nds. So first I have to find curl f. So ijk, partial with respect to x, y, and z, x plus y squared, y plus z squared, z plus x squared. So I component is nothing minus 2z. J component is opposite of 2x minus nothing. K component is nothing minus 2y. So negative 2z, negative 2x, negative 2y. So curl f dot n is negative 2z, negative 2x, negative 2y dot 1, 1, 1 over radical 3, which is negative 2 times x plus y plus z over radical 3. But x plus y plus z is 1 everywhere on the surface, because the equation of this plane is x plus y plus z equals 1. So I could just drop that. So negative 2 over radical 3. So double integral of curl f dot n ds is the negative. This negative here is because it's clockwise. Positive is counterclockwise. And then curl f dot n was negative 2 over radical 3. ds is radical 3 over 2. These all cancel out. Final answer is 1. 10. Div f is partial of p with respect to x plus partial of q with respect to y plus partial of r with respect to z, which is 0, plus 12x squared z squared plus 0, which is 12x squared z squared. So double integral along the surface of f dot ds is a triple integral over the region E of divergence of f dv. So triple integral negative 1 to 1 for x, y, and z, 12x squared z squared dy dx dz. I pick y first because this does not involve y. So it's just 12 times the length of the interval for y, which is 2, 12 times 2. And then negative 1 to 1 x squared z squared dx dz. So x cubed over 3. Z squared, x goes from negative 1 to 1. So take out the 3, and 1 minus a minus 1 becomes 2/3. So 24 times 2/3. Z goes from negative 1 to 1, dz. So that comes out to be 16. Z cubed over 3 from negative 1 to 1. So that's 16 over 3 times 1 minus a minus 1. Final answer is 32 over 3. All right, so that's the solutions to exam 5 for the 11 o'clock section, Calc 3.